Let's talk about derivatives. What is a derivative? Well, by definition, and I found this definition in the dictionary, it's the limit of the ratio of the change in a function to the corresponding change in its independent variable as the latter change approaches zero. Now, honestly, it's probably the worst definition I've ever seen for what a derivative is. And that's going to throw anybody off without a simple definition right from the get-go. But if you want to know the simple definition, you're just looking for the slope. But in this case, we're starting to look for the slope on a curved line, like this one here, and at any very, very specific point. Like, say we're looking for the slope right at this point here. So we need to find the slope of the line. I'm going to try to keep this line as straight as possible. We're trying to find the slope of this line right here. Sorry, that's supposed to be a straight line, but you get the general idea. How do we calculate that slope? Well, we have this slope formula here, delta y over delta x. All that means is the change in y over the change in x. So in order to find that, we have the function of x plus the change in x minus f of x over, this is supposed to be a fraction here, but I didn't put the line there, over the change in x. What you're looking for here, if we have f of x here, you're looking for an ever smaller change between these 2 points. Okay, so moving along, I made this into kind of a real problem. I mean, it's not drawn to scale, but let's say that this graph is representing the equation f of x equals x squared plus 1. Now, in order to find the derivative at a certain point, which I've designated here as x is 1, y is 2, again, not to scale, but we're just gonna, all we're doing here is we're just plugging in numbers. So we've got the f of 1 plus 0.001. We just want a very, very small number. So the 0.001 is just the change in x. You can do 0.0000001 all the way to, an infinitely small numbers is your goal. But if you're using a number like this, you're going to get generally close to the slope. It's not going to be an exact number, and there are ways to find the exact number, but we're not going to go over that in this video. Definitely going to cover some of the shortcuts in the following videos. But anyways, when you figure this out, the f of 1 plus 0.001, that's just, 1.001. And you plug it into this equation, and it comes out to, I'm going to write it over here, 2.002001 minus the f of 1, the function of 1 is 2. You can see that right here on the graph. We're just assuming that it's to scale. So minus the f of 1, which is 2. You can see that it's a very small number, over the change in x, 0.001. This calculates to 2.001. So the slope right here that we're looking for at this point, you can say that that's roughly 2. Rise over run, if you measured it out, it would likely come out really close to 2. Anyways, that's the long and terrible way to find the derivative. It's definitely my least favorite because I know about the shortcuts, and once you learn the shortcuts, you're not going to ever want to go back to this. So check out the next video, and I'm going to be covering the power rule, and hopefully your professors or teachers aren't so mean as to make you use this formula.